day to every one of you. Today we'll be looking at vector integration. Under the vector integration, it will lead us to line integral, volume. We'll look at line integral, surface integral also, and volume integral. So I know you've seen different questions on that. So then we'll also look at it, how you can also learn it and to be able to teach others. So without wasting much of our time, let me quickly share the screen. Then we kick off from there. So you are welcome today. So can you see my screen, please?
Yes, sir.
Okay, good. So vector integral. Under the vector integral, or vector integration, let's put it that way. Under the, if you check your book also, I think something similar is there. But I wouldn't like to go into those details. So for this particular one, we have, let's say, let u or r of u equals to r1, r of u equals to r1 of u I plus r2 of u to j and plus r3 of u k. So be a vector. We said let it be a vector depending on a single scalar. Depending on a single scalar variable u, where r of u, r1 of u, r2 of u, and r3 of u are supposed continuous in a specific interval or specified interval, then we have integral of r of u du to be equals to I into r1 of u du plus j integral of r1 of u, r2 of u du plus k into r3 of u du. So we call this one indefinite integral. Indefinite integral of r of u. If there exists a vector s of u, we have those things. If there exists a vector, if there exists a vector s of u such that r of u equals to d du of s of u, then integral of r of u du is equals to integral of d du of s of u du equals to s of u plus c. You remember when you integrate the differential of u, the s of u, you have to add the constants into it, where c is your arbitrary constant vector independent of u. Don't forget, it's independent of u. And when you have, this is where we have indefinite. But what about definite integral? Let's look at this definite integral. Definite integral is when you have a boundary or you have a bound. For example, you have upper bound and lower bound. So at that point, we'll substitute upper bound and set minus lower bound. For example, let's look at this. The definite integral. So where you have integral of a lower bound and b upper bound out of u, the u. And don't forget, out of u, we said it's s of u there. So we have a, b, d du of s of u du, which implies that s of u plus, okay, let me just scroll up a bit, which is something as integral of, when you integrate it, you have it to be s of u plus c to a, b, which implies upper bound minus lower bound. That is, anywhere you see b, you see b, you see u rather, you substitute it. So it is in same thing as, let's look at it, s of b plus c minus s of a plus c. Because you don't need to, you can't substitute anything in constant. You can open the bracket, let's see, sb plus c minus times this minus s of a minus c, right? This cancel this, so you have s of b minus s of a. So that is what it simply means to have definite integral. But now let's look at it. What about when I have a line integral? Let's look at the line integral. For line integral, I'll give out the definition, then we'll solve them. We will look at the example later. Let's r of u, small r of u, to be s of u I. You remember how when you have a definition of r in vector, y of uj plus z of uk. So where r of u is the position, vector of s comma y comma z. Definite, define a curve C positioning, or let's put it this way, define a curve C joining, let's join, joining points P1 and P2. Where our u is equal to u1 and same u equal to u2, respectively. So what we are saying here is, when you let A equals to x, y, z is equals to A1I plus A2J plus A3K. If you integrate this one, it will be P1 and P2. A dot dr. The same A, we want to integrate it. What does it mean? We have integral of, we use the C. Don't forget the definition of C, A dot dr, which means I have C to be A1 dx plus A2 dy plus A3 dz. If C is a closed curve, if C is a closed curve, we have it to be integral, put the circle here, A dot dr to be integral, the close, A1 dx plus A2 dy plus A3 dz. You can get the definition from there. So also, we use this definition in aerodynamics and fluid mechanics in most cases, for those of us that want to go into that. So we can proceed by solving, we can proceed by solving some of these problems in one way or the other. But let's look at the surface integral. I have surface integral I will not give you the detail, just give you the formula how to go about it because of our time. And I want you to please try and read up some of those things. It will help you to also. So when you have a 3D stuff, we have X, we have Z, we have Y, and we have our X here. This is the origin 0. So at this point, we have, try to look at the surface here. So at this point, we call this one X, and under the surface, we have our N here, and along the line, the S came up. So from here, we said then the X is equal to N dx. And for the integral, we have integral of double integral. You use double integral in this case. S for surface, A dot dx, which is same thing as integral A dot N dx. Like we said here, we define A. So we move on. And the example of surface integral is called flux of A over X. Flux in this spelling is called flux of A over X. So we also proceed, we can also have it to be represented in this form. Our phi dx, which leads to phi n dx, and also we can have the surface Ax the x, but a cross s the s. So we can also have the closed integral in this format by saying the closed integral, this is the sign, it's too big, let me reduce it a bit. This particular sign also means the closed integral. That is, it is indicate integration over the closed surface, over the closed surface. Integration over the closed surface S. So it is over the closed surface S. So let's look at the volume also. By the time we'll just be picking integral I'll give us the definitions, then we continue. Consider a closed surface in enclosing a volume V. Then we have integral of, this is triple integral. And we have A dV, we are working with volume. Then we can also have integral phi dV. So, and we have the example of this, we can call volume integral. Volume can also be called, let me write this one, to consider a closed surface in enclosing a volume V. Then you have this. So the examples are of volume. We have different examples. These are the examples that I gave us now. And they can also call it space integral. That is, these are examples of volume integral or space integral. So let's start with the example, one after the other from the vector integration. Number one, if R of U is equals to U minus U squared I plus 2U cubed J minus 3K, the question says, find A, integral R of U du, and B, integral, this is definite, indefinite. The first one is indefinite, the second one is definite. 1 to 2 R of U du. Please, how do you call, when you have one, what does it represent from the up, the one I gave you? Somebody should talk, please. From here, what does 1 represent?
Minus, that's.
No, this one from here.
What
does 1 represent?
A.
What is A?
Lower limit, sir.
That's lower limit. Thank you. Lower limit or lower bound. And B is what?
Upper bound.
Upper bound.
Upper bound. Yes. So let's go ahead and solve this problem. So what do we have to do here is just to solve this solution, put them in integral. So we are given r of u du equals to integral of, what is u? Let's put them. U minus u squared I plus 2u cubed j minus 3k du. So I can separate them by saying I should become, or my component should be in front, and put u minus u cubed to the u plus j integral of 2u cubed du minus k, or still put it plus, you can still say plus integral of minus 3k, 3 du. So if I want to solve this one, I can say, I can easily solve them one after the other. When you integrate u, what do you have?
U square over 2, sir.
U square over 2 minus u3 over 3. Do you agree?
Yes, sir.
Yes, sir.
I plus j, or you can just hold your j, put it at the back, since we have started integrating. So you have 2u raised to power 4
Over 4.
over 4 over 4 what? J minus 3uk. Everything plus what?
C.
But let me say this. Let me add, because each of them stand alone. Let's do it this way. I can as well put my plus C1. Let me call this one C1, then C2, J. Then I can go ahead and call this one C3. I can call this one plus C3K. Is that okay?
Yes, sir.
Okay. Plus C3K. So in this case now, we can begin to still keep this one like this, plus C3K. So we can now collate all the C together. If you are collating all the C together, I'm going to have U2 over 2 minus U3 over 3 I. This one here 2, here 1. So you have U4 over 2 J minus 3U. Okay, remember here you still have C. So we now said plus C1I plus C2K, then plus C3K.
It's C2J.
C2J, thank you. C2J. So you see what we have now. Then you agree with me that everything here is still C. Do you agree?
Yes, sir.
Yes, sir.
Now we can go ahead and say that, but we just have to show it. You can go ahead and write it off by saying U2 over 2 minus U3 over 3 I plus U4 over 2J minus 3UK plus C, where C is constant factor. We all know that. That's what they asked you to solve in question 1A. Now question B. From A, we use the same 1 to 2, R of U du. Using our expression in A, just substitute them here. You don't need to go through it again. So all I need to do is just to put this one in bracket by saying U2 over 2 minus U3 over 3 I plus U4 over 2 J minus 3UK. Everything, then plus C. Don't forget your plus C, although it will cancel, but you still need to put it there. 1 to 2. Remember, upper limit minus lower limit. If you do it very well in your own case, you will have this. I will just write it out and you can punch your calculator and get it right. So it's going to be, let's substitute 2 first. 2 raised to power 2 over 2 minus 2 raised to power 3 over 3 I plus 2 raised to power 4 over 2 J minus 3 raised to power 2, 3 multiplied by 2K. So plus C minus lower limit, 1 raised to power 2 over 2. You remember now, 1 raised to power 3 over 3 I plus 1 raised to power 4 over 2J minus 3 into 1K plus C. So when you open the bracket, you discover that at the end of the day, if I open the bracket, something will surely be affecting one another. So let's take note of that. So let's, if you substitute it now, if you do it very well, you are going to have minus 55 over 6I plus 15 over 2J minus 3K. So on your own, open the bracket, punch your calculator one after the other. The C will cancel. By the time you open the bracket here with negative, this one will turn to negative and it will cancel the positive. So take note of that. Then you can solve the rest. Then by the time you are adding everything together, I must be add to I, J must add to J, and K must add to K. So you have this at the end of the day. So take note. Any question, please? Any question?
No, sir.
No, sir.
Silence means no question. Okay, that's fantastic. Okay, let's look at number 2. Let's look at another example. So in this case, we'll be talking about acceleration and fluid. The acceleration of a particle at any time, t, at any time, t greater or equals to 0, is given by A equals to dv over dt is equals to 12. Can you please mute yourself? So is equals to 12 2 cos t I minus 8 sine 2tj Just
Hello.
Sir is muted. I think he off the screen. I think he went to do something. It's going to be back very soon.
Okay, okay. Kausara, continue now.
For where?
okay. Sorry for the interruption. Okay, I'm giving you the question now. So at this point, we can also look at it in different way. We have the volume, the V over the T, then plus 16 TK. So if the velocity V and displacement R are 0 at T, find V and R at any time at any time. So the solution is very simple. Let's look at integration now. Can we try the integration? Can you integrate this one? Any of us? Can we try it?
It is 12 divided by 6 sine 2t I.
Yes. Okay, let's write it out for the others to also benefit from it. So when you are given this question, what do we need to do? Is to find, we have our V to be integral of I, 12 cos 2t dt minus j 8 sine 2t dt plus k integral of 16t dt. So we can go ahead and solve this problem amicably. Can we solve it now?
Yes, sir. Mr. Shola, please continue. Can you hear me, Mr. Shola?
What do you say, Tayo? Mumbo,
Okay, sir.
just give me 1 minute, please.
Okay, sir.
Sorry, guys. Have you finished it? Are we there?
Yes, sir.
So what's the final answer for this?
So the final answer is V is equals to 6 sine 2t I plus 4 cos 2t j plus 8t squared, sir,
No,
plus c.
no. Remember that the question, read the question again. If the velocity v and displacement r are 0 at time t, meaning that after you integrate this, now let's do it together now. What it simply means is we have 12 over 2, because when you differentiate cos t, you have sine t, right? So you have 12 2 sine 2t I minus, when you differentiate sine, you have minus cos, right? It turns to positive 8 over 2. Where are we getting over 2? Somebody is asking that question. So it's very simple. What we are doing is take your 8 out, you have 1 all over 2 cos 2t. So that is why we get it. j. The same thing happened to this. Then we have plus 16t squared over 2. Everything plus c. Let's say plus c1. So at the end of the day, you have 6 sine 2t I plus 4 cos 2tj plus 8t squared, okay, plus c1. Now, putting v to be 0, remember everything here we are doing is b, everything here is b, and when t also equals to 0, we have, so anywhere you see t, substitute 0 there. You said 0 equals to 6 sine 0, right?
Yes, sir.
Then plus 4 cos 2 of 0 j, then plus 8 of 0 k plus c1. So at the end of the day, you have it to be 0 equals to 0. This is 0, 0i plus cos 0 is what? 1. So 1 multiplied 4, 4j plus what? 0k plus c1. So which implies that c1 is equals to minus 4j. Do you agree?
Yes, sir.
Daniel, do you agree? Or you cannot talk? I saw one Daniel here. Are you there, Daniel? Samuel, are you there?
Yes, sir.
Do you understand
I can hear
how
you,
I
sir.
got? Okay. Do you understand? Do you get the way I got minus 4j?
No, I just
The
joined. That's why
C1
I'm
subject of
trying to
formula, sir.
follow up.
Okay, no problem. Okay, let's continue. So we can now say our equation we now write, then we have it to be v equals to 6 sine 2tji plus, remember the cos, 4 cos 2t minus, now we have 4j now, minus 4, everything j plus 8t squared. Okay, so that's our new v now. So that we can go ahead and say the r over the t. For us to integrate r over the t now, what do we need to do?
I'm going to integrate v, sir.
Yes. So when you integrate it, what do you have? You have I integral of 6 sine 2t dt plus j integral of a bracket 4 cos 2t minus 4 dt plus integral k at squared dt. So at the end of the day, you have I. If I integrate this very well, what do you have? You have I. Let me just, when you integrate sine, what do you have?
Cos. Minus cos.
minus cos. Minus, we have 6 in bracket 1 all over 2 cos t, cos 2t rather.
Yeah, cos 2t.
Cos 2ti. Then let's integrate this one out one after the other. Plus, when you integrate this, what do you have? Let me just put this together. When you integrate cos 2t again, what do you have? Sin 2t. We have 1 over 2.
Yeah.
Are we together now?
Yes, sir.
So you have 2 sin 2t. Let me just cut it like that. 4t j plus, when you integrate cos, when you 8t squared, you have 8 over 3 t
8 over 3 cube. Yeah.
plus c2 k. Don't forget the k. So here we have 1, here 3. So I can say I have 3 cos, negative 3 cos 2t I plus 2 in brackets sin 2t minus 4tj, then plus 8 over 3 t cubed k plus c2. So at this point, putting r at t equals to 0, when t equals to 0, r equals to 0, what happened to this particular equation? You have it to be 0 equals to negative 3 cos 0 I plus 2 sin 0 minus 4 of 0 j plus 8 over 3 0 k plus c2. So at the end of the day, what do we have? We have c2 equals to 3i. Do you agree with me?
Yes, sir. Because
Yeah.
0 is 1.
So by the time you substitute back into the equation, our r will be, remember this is 3i. Put it there. 3 minus 3 cos 2ti plus 2 sin 2t minus 4t. This is where we are substituting into. We are substituting back to this place. Into this place. Don't forget. So are you getting it now? J this is J plus 8 over 3 raised to power 3k. So that is what they asked us to solve. So when you see this kind of question in your exam, I think for the past question, I think we have similar question like that. Yes or no?
I've not seen the last question.
Yes, sir.
Yes, sir.
Oh, okay. Let's check. Let me check. I think I have one here. Okay. Look at what we've solved something similar here. Question 1, we've solved virtually everything in question 1. So derivative, define the following. You remember I gave you all this. Let's take notes and write it out by ourselves. Take your time and do it. If you miss the class, go and watch the video. So we are moving towards this particular aspect now. Your question is very cheap. All you need to do is just to learn how to maintain your status quo from there. So you can see, let me see whether I have another one. Another one is here. Can you see it?
Yes.
Yes, sir.
Okay. We are not getting to the Stokes theorem. We are still moving towards that place. So these are the questions that you should. So we are moving towards you can see volume integral, moving towards it. And by the time we solve those ones, I think your work is simple. Where is your timetable out now?
No, sir.
Okay, let's continue. Before the timetable is out, we'll have finished everything. By the special grace of God, we'll try. If you could continue in this pace, I think we are going to get it right. Okay, let's look at the line integral. The line integral, what does it mean? How do we solve the line integral? This is just a definite and indefinite. Now we're going to line integral. I will not waste much time on definition. If you need the definition, please check your books. Some definitions are there, but I will just go straight to the point. If A is equals to 3x squared plus 6yi minus 14yz j plus 20xz squared k. Evaluate integral of line integral a dot the r from 0, 0 in 3 plane to 1, 1, 1. So along the following, part C, A, when s is equals to t, y is equals to t squared, and z is equals to t cubed. They can give you any other thing. B, the straight line from 0, 0, 1, 0 to 1, 0, 0. Then to 1, 1, 0, and then to 1, 1, 1. C, the straight line joining 0, 0, 0 and 1, 1, 1. So we have integral of C A dot R. So for us to solve this, we already have what we need to solve it, but let's look at the way it works. Solution. Integral, the line integral a dot dr will be (3x squared plus 6yi minus 14y zj plus 20 z squared k. Everything dots. The si plus the yj plus the zk. So remember when we are doing dots, when dot I multiply dot I, what happened to it?
Minus
Becomes
1.
one.
Minus
It's
1.
what?
One.
Minus 1.
One. We are dealing with dots, not cross.
We are dealing with dots. When dot I multiplied by dot I, remember you are not in complex play. Don't bring complex into this. Are you getting it?
Yeah.
Is that Daniel?
Yes.
You remember in complex when you said I dot I is I squared, which is -1. But in effector, I dot I is 1. Please take note of that.
Okay.
3x squared plus 6y. I dot I squared is it nullified. That's 1. That's why we call it the x. So you will not represent it with any I plus whatever again. So we have negative minus dy, j dot j will be 1, 14yz dy plus 20x squared dz. So that is what we want to achieve by this. So we proceed to solve question A. The A part says, along this path, where your s is equals to t, your y is equals to t squared, your z is equals to t cubed. So you need to substitute them. When you substitute them, then remember that it also gives us this part where we are also moving towards t equals to, at point t equals to 0, it corresponds that at point t equals to 0, as lower bound and upper bound is t equals to 1. So that is what we are dealing with. So let's move on. So A, we have if t is equals to, if s is equals to t, if s is equals to t, y is equals to t squared, z is equals to t cubed at point 0, 1, 0, 0, and 1, 1, 1. Corresponding or correspond, let's just use correspond to t equals to 0, and t equals to 1, respectively. So we have this to be integral of 0 to 1. It is t equals to 0, 1. So I will now be changing it one after the other. 3. What is x?
S is equals to T.
S is equal to t. So we have t squared here. Plus 6. What is y?
T square.
6t square.
So we have dt. Are you getting it now?
Yes, sir.
Because the s is the s dt. Because dx means dt. Take note of that. Minus. Remember, all this integral is for all of them. 14. What is y? T squared
T square.
in brackets. What is z?
T
T
cube.
cube.
The y is what?
2T dt.
No, the T. The T.
2T dt.
The T square.
Not T
Don't worry,
square.
just write it this way. Please off your mic. That person. Plus 20t. I hope you are getting it.
Yes.
Now, t cube raised to power 2. The t raised to power 3. Any question? I just substitute the way it is. I've not solved anything. So you agree with me when I'm trying to solve them now. Let's, first of all, the first one, we don't have a problem with this. Let me pick another marker so that we can resolve this one amicably. How do we resolve this?
Sir, are we not having constancy?
We will not solve it, though.
Okay, sir.
We will
I
not
think
solve
we integrate them one after the other.
No, you have to harmonize. You don't have t like this. Each of them must represent single t. So that is when your law of indices and differentiation will come to pass. So let's look at this now. It simply means you have to differentiate this one. That's why Tayo was saying 2t dt. So when you differentiate this, you have for t. We can harmonize this one together by calling t5, right?
Yes, sir.
Do you agree?
Yes.
Yes, sir.
Now we have t5 already. Now let's differentiate this one. 2t dt. Do you agree?
Yes, sir.
People are silent now. Do you agree?
Yes,
Yes,
I
sir.
agree.
Okay. 2 multiplied by 4. T.
That's 28.
Do you agree this?
Yes, sir.
T6, yes.
Yeah.
Perfect.
So that is what will happen to this. Then you go to this and resolve this one too. What will happen to this one will be 2t7. Do you agree? And differentiate
Yes,
what
sir.
is here.
Yes, yes.
3t squared. 3t squared dt.
dt.
So at the end of the day, you have 60t 9 dt. Do you agree?
Yes, sir.
So let's now go back to our equation and solve them and put it there. So we have integral. You can add this together by saying 9t squared dt 0 to 1 minus 28t6 dt plus 60t9 dt. So if you want to integrate this one, any question on that? So let's integrate. You have 9t cubed over 3
Over 3.
minus 28t7 over 7
Over 7.
plus
60t10 over 10.
60t10 over 10 plus what?
Plus C.
Plus C.
C.
Plus c. We don't need c now. Remember I told you, anytime you have a definite integral, you don't need c because you have the upper bound and lower bound to substitute already.
Okay.
Automatically it will cancel because upper bound and lower bound negatively affect the other side, it will cancel. Year 1, year 3, year 1, year 4, year 1, year 6. So if you substitute it very well, you have 3t cubed minus 4t7 plus 6t10. 0 to 1. When you do it very well, you have 5. Go and do it by yourself. Upper limit minus lower limit. That is where you have 5. Any question? That is A. Use the same mindset to solve for B and to solve for C. Do I need to explain B and C for you?
So one of them, sir. And we'll try the other one ourselves.
Why one of them? Why not you guys solve everything? Why?
So
Because-
the second
okay,
one,
fine.
I think we have plenty.
You can
linking
give us
from
the answer.
0,
So when
1,
we try, we know if we are right or wrong.
Oh, I should give you the answer. Do you all agree?
Yes. So that when we
Yes,
solve, if
no,
we are right
yes,
or wrong,
sir.
we know.
Yes, I solve one, sir.
Thank you,
Okay,
sir.
let's look at the one first. I don't want to put all of you into issue. Okay, if you want to solve first one along the B says along straight line, right? Along the straight line from 0, 0, 0 to 1, 0, 0. So it still vary, this which implies that y equals to 0, z equals to 0, right? And
Yes, sir.
our dy is equals to 0, dy equals to 0, y x varies from 0 to 1. Remember that only this remain 1, others are 0. So that is what we are saying. Then the integral part over this is very simple, the way we solve the first one. So what we need to do is just to go to integral part from the question. So it's going to be integral x equals to 0 to 1. So we have 3x squared. You go back to that original one, to the main question here. We are working with this now. Are you getting it? So let's give me if you have it, can you call it for me?
3x squared plus 6y
6y,
I, then
the
minus
x.
14.
You can't
Yes.
get I, madam.
Okay, yes,
There-
ma, the x.
There's no
Yeah.
I again. Minus 14.
YZ.
what?
YZ the y.
The y,
Plus 20x z squared z.
plus 20
X z squared the z.
So don't forget the y equals to 0, the z also equals to 0 at this point. So if I want to do it now, I'll just say x equals to 0 to 1. Then I'll put it 3x squared because x is vary plus 6 of 0, the x minus 14 of 0 minus 0 and minus 0 plus 20 of 0, 0 squared and 0. You can put the square if you want it. So I already eliminate those parts that is not necessary. So I have s equals to 0 to 1. So it's going to be 3s squared dx. So let's integrate this one. What do you have?
3s cubed over 3. S cubed.
S cubed,
Yeah.
0 to 1. When you solve it very well, you have 1.
1. Yeah.
Yes. So remember that we still have another, how many parts we are given?
3 parts, sir.
So another part we are given says, let me just check my book for question. I don't want to be flipping it. It said, along the straight line, from 1, 0, 0 to 1, 1, 0. So it simply means s is equals to 1, z is equals to 0, the s is equals to 0, the z is equals to 0. Y varies from 0 to 1.
1.
So if y varies from 0 to 1, let's integrate it. We have integral of y equals to 0 to 1. Remember, s is equals to 1 in this case. We have 3 of 1 squared plus 6y. The s is equals to 0, put the 0 here. Minus 40y, z is equals to 0 dy, plus 20 of 1 and 0 squared. The z is also 0. So at the end of the day, everything here is 0. Or do you have anything to gain from there? No. Are you following me?
Yes, sir.
Yes, sir.
So along the another part, along the straight line, from 1, 1, 0 to 1, 1, 1. This is simple as s is equals to 1, y is equals to 1, the s is equals to 0, the y is equals to 0, y, z varies. from 0 to 1. You can see from 0 here to 1 here. So it varies. So we can substitute it here. Z equals to 0 to 1. We have a 3 of 1 squared plus 6 of 1, everything multiplied by 0, minus 14 of 1, Z of 0, because everything here is the y is also 0, so plus 20 of 1 and Z squared dz. So at the end of the day, this will give us integral of Z equals to 0, 1, 20Z squared dz. When you integrate this one very well, you have 20 over 3. That's what you will get. So having done this, you have to add all. Remember that when you integrate this, I hope you still recollect what you are going to have. Let's do it.
Yes.
Z cube. So at the end of the day, you have 20 over 3. So remember that. So you have to add everything now. When you add everything, it's going to be line A dot the R will be 1. Remember, when we do the S, when the X is vary, we have 1. When the Z, Y is vary, we have 0. We add it together, plus 0 plus 20 over 3. So at the end of the day, the final answer will be 23 over 3. Please don't forget. So you can go ahead and do the one of C now that you have idea of what we are doing.
Yes, sir.
So I believe that is okay for every one
Yes,
of
sir.
us to do. Any question? So this is only one out of the 3. So the next class will be moving towards, we'll solve one example and volume and the service. We'll also do the one of service and see how we can complete vector integration before we move to divergence theorem, stroke theorem, and I think
Green's theorem, sir.
and Green's theorem. Let me stop sharing. Yes, Daniel, you want to say something? Go ahead.
I just started the class today. I didn't know we've been having online classes, and
Really?
the few times I've went today, so it's an interesting class. So I don't think I'll miss any further classes. But all the past lectures, I don't know if they are recorded and loaded on the
Definitely. That means you've not been visited your portal, because if you've been visited, if you have been very, let me see your face. What?
Let's see your face. Let's
Which
come
of the that have you been in my class before, or this is your first class?
It's my first class.
Okay. Okay. We've been having the class. We've been having the class, and it has been an interesting class. So, and as you can see, what we've been doing so far, an interesting one. The videos are there.
I really enjoyed today's class. Yeah.
You're welcome. The videos are there.
Yeah, thank you, sir.
You're welcome, sir. The videos are there
Okay.
on the YouTube channel, and it's also on the platform. Are you on the WhatsApp group?
Yes, I just joined. That's how I.
Okay, you just joined.
We have lectures.
Have you seen this? Are you using the email the National Open University opened for you guys?
Yes, that's why.